mesomeric effect. ठीक है? This is the strongest, and then we have hyperconjugation, and the weakest effect is inductive effect. Fine.
Okay.
Since we have benzene ring like this, and let us suppose we have some group here, and then we have some group on this ortho position. ठीक है? OCH3 मान लेते हैं. Now, when this is OCH3 here, this OCH3 is going to show plus M effect also, and it is going to show, because of the oxygen atom, minus I effect. Because oxygen atom is more electron negative, it is going to pull electron density. But since mesomeric effect is dominant, like it is too high, mesomeric effect, जो effect होता है, it's very strong effect. That is why we don't consider minus I. Meta position में क्या होता है? If you have any group, let us suppose you have OCH3 here in the meta position, the mesomeric effect does not work here. And because mesomeric effect does not work here, we can just look at we have to look at the inductive effect only. Okay? So it's not that the inductive effect works on the meta position, it's rather mesomeric effect does not work on the meta position. That is why the most dominating after mesomeric effect that work is the inductive effect. Okay? So we say that we have to look for, in meta position, we have to look for inductive effect. Make sense?
Okay.
Yes, anything else?
Sir, and that question I sent you, I didn't get that partial pressure law.
Partial pressure law. ठीक है. We will do that question today.
Okay.
Because if you saw, there is equilibrium in there, no?
Yeah.
But it is from thermodynamics, right? I
Yes.
guess. You see that question. Actually, these problems they arise because the states of matter chapter is not there in the syllabus, but उसमें से कुछ content है. For example, PV is equal to nRT. I mean, this is also coming from states of matter. So this is directly used in the thermodynamics chapter. So anyhow, they have to work around this problem, CBSE and NCERT. And also, bigger problem is NCERT. They have released new textbooks. I mean, those new textbooks, they don't even have states of matter. So they are directly using many of the formulas, which is a bigger problem. So where are the other students? आज कोई नहीं है.
So did we do electromagnetic effect separately in the notes?
Did we not do it? I may not have also done because I generally give it as homework. Maybe कहीं हमने homework में बोला हो. Minus I, so the reactive intermediates, and after that we have the it's. So we have just written it, and maybe I told in this class the electromagnetic effect आप लोग खुद से देख लीजिएगा.
Yes.
But if you want to understand what it is, then I can explain it right now. So, for example, अगर आपके पास let's suppose we have carbon, we have CH3, carbon, double bond O, and then we have CH3 here, like this. ठीक है? Now, let's suppose there is a nucleophile. So nucleophile is electron rich. So as soon as this nucleophile will come near to this site, so what's going to happen? This carbon atom will break this pi bond. It will convert to CH3, CO negative, carbon positive, and CH3. So that the attack of this nucleophile is a bit easy. As soon as, see, in the nucleophile आएगा, suppose nucleophile is removed, and this is 1, this is 2. So there are 2 states for this acetone molecule. When the nucleophile is, let's suppose, not here, then it is in the first form. When it is there, then it is in the second form. ठीक, जैसे आएगा तो ये second form में transform हो जाएगा, हट जाएगा, then it will be in the first form. So that is why it is temporary. As soon as the nucleophile will approach, the pi bond will break into positive and negative. जैसे हटेगा तो वैसे ही वापस से pi bond form हो जाएगा. ठीक है, so it is also shifting of electron, but this shift is temporary. Make sense now, हर्षा?
Yes.
ठीक है. और आपको अगर सवाल आएगा ना तो उसमें कुछ एप्लीकेशन नहीं है इलेक्ट्रोमैग्नेटिक इफेक्ट का कुछ खास, तो आपको डेफिनेशन ही आएगा, अगर आएगा तो सिंपल. ठीक है. चलिए, आई थिंक आई शुड स्टार्ट द क्लास बिकॉज आई डोंट नो वेयर द अदर स्टूडेंट्स आर. स्टार्टिंग विथ योर क्वेश्चन, हर्षा. Yes. So the question says at 60 degree at 60 degrees Celsius into, so dinitrogen tetraoxide, sorry, dinitrogen tetraoxide N2O4 is 50% dissociated, is 50% dissociated. They're asking calculate delta G naught at this temperature, and 1 atm is the pressure they have given. So there are a few problems in this particular question. एक सबसे पहले, you need to know what is the dissociation of N2O4 going to give you. So dissociation of N2O4, it just gives you NO2. It gives dissociated. That means both of these things are there. You have 2 moles of NO2 when we balance it. When they are saying it is 50% dissociated, that means you have some amount of N2O4 and some amount of NO2 also present, and that is why there is an equilibrium. Okay. Now, next thing that I can say is इसके बारे में आप ऐसे समझ लीजिए, initial, ठीक, then there will be change, and then there will be equilibrium. So initial, I will start with 1 mole of N2O4, and initially I will not have any NO. What is the change? 50% is dissociated. That means 0.5 moles of 0.5 moles of N2O4 has been dissociated, and after dissociation it is going to form double the amount. So 0.5 का क्या हो जाएगा? 1 mole of NO2 will be formed. Make sense?
Yes,
Does
sir.
this make sense? ठीक है. That means I can say here you will have 1 minus 0.5. कितना हो जाएगा ये? 0.5. 0.5 moles of N2O4 will be there, and there will be 1 mole of NO2. Make sense? Yes or no?
Yes, sir.
Okay. Now, since we have done equilibrium, and this question is going to make sense only if we have done this particular question. ठीक है. अच्छा, एक और चीज आप यहाँ पे अगर खाली पास से देखेंगे, they also said this one that we have taken ना, this one is coming from here 180, because the pressure inside the container will be because of N2O4, और N2O4 हमने स्टार्ट किया 1 atm लेके, है ना? तो 1 atm था, उसके बाद डिसोसिएट हो गया. मेक सेंस राइट नाउ? यस और नो, प्लीज टेल मी.
Sir, so we are calculating the pressure in initial.
हाँ, इनिशियली वी हैव दिस 1 atm प्रेशर. अब 1 मोल ले, मतलब वी कैन टॉक अबाउट 1 मोल आल्सो, बट यू कैन सी दैट हियर दे हैव गिवन 1 atm. अगर atm नहीं देते फिर हम लोग मोल्स लेके कैलकुलेट करते, दैट्स अनदर थिंग, बट दे हैव आल्सो गिवन यू 1 atm, नो? So that pressure is only because of N2O4 that we are having, and when it dissociated then we have this whole situation.
Okay, sir.
Make sense?
Yes.
ठीक है. So now next you can write yes, so we can have Kp ना, यहाँ पे हम Kp लिख सकते हैं for this reaction, and then we can relate it with delta G. I think we have done this ना, delta G and equilibrium constant हमने लिखा है, नहीं लिखा है? लिखा है ना, लास्ट क्लास में किया था हम लोगों ने. ठीक है, फाइन. So Kp will be equal to how much? Concentration of product divided by concentration of reactant. Make sense?
Yes.
And is there anything we are left with? This will be equal to how much? 2, no? We are getting something wrong. If it would be 2, let's see. At 60 degrees Celsius, dinitrogen tetroxide is 50% dissociated. Calculate the standard free energy change at this temperature and 1 atmosphere. Hopefully 1 atmosphere is the pressure of the gas only. Now whether it is pressure of gas at equilibrium or before equilibrium, that I cannot say. What would happen if we take moles? If we take moles here, then this is 0.5 moles, and here we have NO2 ka 1 mole of NO2. Initially we have 1 mole of N2O4. At last we have 1 mole of. So number of moles of N2O4 is equal to 0.5. Number of moles of NO2 is equal to 1. And total moles कितना हो जाएगा? Total will be equal to 1.5. So mole fraction we can calculate, उसके बाद निकाल सकते हैं. N2O4 will be equal to 0.5 divided by 1.5. Number of moles of N2O4 divided by total moles, and mole fraction of NO2 will be equal to 1 upon 1.5. So from here we can calculate mole fraction, फिर इसके बाद pressure. Maybe that's why we are having a difficulty, because see, एक दिक्कत 1 atm लेने में ये हो रही है कि this 1 atm can be the initial or the equilibrium also, so we really don't know. So that is why I think I have to ignore 1 atm right now. ठीक है, तो if we take number of moles, then we will get mole fraction, and once we get the mole fraction, अब आप यहाँ पे ये देखिए, सी पीवी इज इक्वल टू एनआरटी, जो मेन आपका डाल्टन लॉ ऑफ पार्शियल प्रेशर है ना, उसके लिए पीवी इज इक्वल टू एनआरटी है। एंड यू ऑल्सो नो दैट द टोटल प्रेशर this is equal to, the total pressure will be because of number of moles of A plus number of moles of B, है ना। हम इसको N2O4 को A ले लेते हैं और NO2 को B ले लेते हैं। मेक सेंस टिल हियर? द टोटल
Yes.
प्रेशर इन द सिस्टम विल बी PA प्लस PP। ठीक है। अच्छा, टोटल प्रेशर आपके पास P टोटल हो गया, दिस विल बी इक्वल टू, अब यहाँ पे आप ऐसे देख सकते हैं, P टोटल दिस विल बी इक्वल टू PA प्लस PB। नाउ we need to determine what is PA and PB, है ना। and mode fraction, total pressure has been given। अच्छा, टोटल प्रेशर वही इक्विलिब्रियम वाला 1 atm लेके चल रहे थे। ओके, सो PA will be equal to how much? PA will be equal to number of moles, PA is equal to number of moles RT, number of moles of A divided by volume। PB will be equal to number of moles of B RT upon volume। Now see, this is number of moles of A upon RT and volume, and we can see number of moles divided by volume. I'm missing something. Am I missing? Give me a second. Mole fraction of A will be equal to partial pressure due to A divided by total pressure। ठीक है, दैट मींस PA अपॉन PT कर देंगे तो कहीं आना चाहिए। ठीक है, सी गाइस, ठीक, गॉट इट। सी, लेट्स सपोज व्हाट इज PA अपॉन P टोटल। ठीक है, तो PA क्या होगा? नंबर ऑफ मोल्स ऑफ A RT डिवाइड बाय वॉल्यूम। P टोटल क्या होगा? नंबर ऑफ मोल्स ऑफ A प्लस नंबर ऑफ मोल्स ऑफ B, बिकॉज दीज आर द ओनली मोल्स, RT whole upon V। मेक सेंस?
Yes.
Now we can cancel RT and RT, we can cancel V and V. You will get this as number of moles of A divided by number of moles of A plus B. And this thing is what? This is chi E. This makes sense?
Yes.
So now we can say that chi A mole fraction is equal to partial pressure due to A divided by the total pressure. And from here we can calculate the partial pressure due to A will be equal to the mole fraction of A into the total pressure, and the partial pressure of B will be equal to the mole fraction of B into the total pressure. And chi A, we have got this as how much? 0.5 upon 1.5, 0.5 upon 1.5 into total pressure is 1. Partial pressure of B we have found as 1 upon 1.5 into total pressure is 1. So if we calculate this value, 0.53 I think, है ना? This will be 1 by 3, and PB is equal to how much? PB will be equal to 2 by 3, I guess. Because if I multiply 2 by 2 here, this will get 3 and this will get 2. This will be 2 by 3. So from here, so that was equilibrium temperature. 180 was equilibrium temperature. Equilibrium pressure, my bad. Then we have Kp. Kp will be equal to partial pressure of B square divided by partial pressure of A, because NO2 is having the stoichiometry 2. PB is equal to 2 by 3 square divided by P is equal to 1 by 3. So it will be equal to 2 by 3 into 2 by 3 divided by 1 by 3. 3 and 3 will be cancelled, and it will be 4 by 3. So this is Kp. Once we have got the Kp, then we can apply the formula. Delta G naught, it is equal to minus RT ln K. You can write this as minus 2.303 into R value will be 8.314 or 8.3 into temperature is 60 degrees Celsius. 60 degrees Celsius, that means 333. So 33. And what is ln k? ln k नहीं log आएगा, log 4/3. So minus 2.303 into 8.3 into 333 log 4 minus log 3. ठीक है? Now you need to solve log 4 and log 3. Do you know what is the value of log 4, log 3? These things? अभी शायद नहीं पता होगा आपको ना? Do you know the values, Harsha?
Sir, log 3, I guess it's 0.48.
0.48. Log 4 is 0.6. So this will be 0.12 approximately. Minus 2.303 into 8.3 into 333 into 0.12. Log 3 is 0.48. Log 4 is 0.6.
Okay.
Okay, so you need to calculate this one. Yeah, moving on to the next part, that is ionic equilibrium. है ना? We have to start ionic equilibrium.
Sir, can you scroll up, please?
A bit more.
No, sir, no.
Where's this part? Done, Harsha? Let me know once you're done.
Yes, sir, done.
Okay. Right, next. Ionic equilibrium. Ionic equilibrium. What is ionic equilibrium? The substance ionic equilibrium में ना सबसे पहले हम लोग आयंस के बारे में समझेंगे. ठीक है? Please write the substance that conduct electricity in molten state or in aqueous state is called electrolyte. ठीक है? And electrolytes, these are present in form of ions. तो electrolyte क्या होगी? जैसे electrolyte होगा आपका NaOH. Then it will be HCl, KOH, can have MgCl2. ठीक है? So these conduct electricity. और ये जो electrolyte है ना, जैसे मान लीजिए आपके पास NaCl है. So NaCl in molten state or in aqueous state, it is in the form of Na positive and Cl negative ions. तो ये आपका है electrolyte. and this NaCl, these are ions. इसमें एक cation है, दूसरा anion. Make sense?
Yes, sir.
Now, then next is electrolyte. They are divided into two categories. Some of the electrolyte, they completely dissociate when you add it in aqueous medium. So you have strong and we have weak. So on the basis of the dissociation that we are having now, strong electrolyte, they dissociate completely, and the weak electrolytes, they dissociate partially. So they don't completely dissociate. So इसके examples में है, for example, you have NaCl, KCl, KBr, you have HCl, MgCl2, H2SO4. So these are strong electrolytes and they dissociate. Now, how to identify strong and weak? So it is a bit not very straightforward, है ना? तो जब आप आगे पढ़िएगा तो वीक में भी परसेंटेज डिसोसिएशन होता है. So weak maybe you have some which dissociate 80%, some dissociate only 50%, some dissociate only 10%. So there is not a cutoff value like that. But as soon as you start completing the equilibrium chapter, you will have an idea what are strong and what are generally weak. तो देखिए strong में आपके पास हमेशा you will mostly see inorganic compounds. In weak, you will generally see organic compounds. For example, CH3 COOH, acetic acid. This is a weak acid. Similarly, ammonium hydroxide, NH4OH. This is also a weak. We have HCN. Then we have ammonia. All of these are what? Covalently bonded molecules. And these are generally speaking, these are weak electrolytes. They do not dissociate completely. Now, when you look at these different types of electrolytes, these electrolytes are either acid, or they are base, or they are salts. Now, we need to dive into details of acids and base, because when acids and base reacts, they make salts. So if you understand acid and base very perfectly, then there are some properties that we can predict about the salts also. So you'll first start with acids and base, because as you can see, most of these compounds are either acid, base, or salts. So salts का भी ज़्यादा detail में पढ़ने की जरूरत नहीं, because salt is actually a byproduct when acids and bases react. So it starts with acid-base concepts. So there are different definitions of acid and base that has been given. Acid-base concepts. No, the first concept, it was given by Arrhenius, and this is the most common concept also, Arrhenius concept. So Arrhenius plainly said that acids give H plus ions in water. आप पानी में डालेंगे तो H plus ion की concentration बढ़ जाएगी. And he said bases give OH negative ions in water. A simple definition by Arrhenius. The second definition, the second concept was given by Bronsted-Lowry. Bronsted-Lowry concept. Now his definition was, it was only on the basis of H plus ions. So Bronsted, he said that acids, they give, या फिर आप इसको बोल दीजिए loses H plus ions. And he said that if you have a base, then base is going to accept or gain H plus ions. Now, on the basis of this Bronsted-Lowry concept, something known as conjugate acid base pairs. Okay, so when acid they lose H plus ion, the product form it is known as conjugate बेस और बेस से निकालेगा तो एसिड बनेगा. ठीक है. सो जनरली स्पीकिंग आपके पास क्या कॉन्जुगेट एसिड बेस पेयर्स. ठीक है. तो आप इसको याद कैसे रखेंगे, बहुत आसान है इसको याद रखना. इफ यू वांट टू मेक अ कॉन्जुगेट एसिड तो आप क्या कर दीजिए, ऐड H प्लस, जो भी स्पीशी दिया ना उसमें H प्लस डाल दीजिए टू मेक कॉन्जुगेट एसिड. और अगर आपको कॉन्जुगेट बेस बनाना है तो क्या कर दीजिए, रिमूव H प्लस, remove H plus to make conjugate base. ठीक है. ऑन द बेसिस ऑफ दिस वी आर गोइंग टू डू अ प्रॉब्लम, है ना. सवाल करते हैं हम लोग. प्लीज कॉपी दिस डाउन, देन वी विल डू अ क्वेश्चन. दिस इज इंपॉर्टेंट कंसेप्ट है ना, कॉन्जुगेट एसिड से सवाल आते हैं. जस्ट लेट मी नो वंस यू आर डन हर्षा writing till remove H plus to make conjugate base.
Done, sir.
Done. Now first question, what is meant by conjugate acid base pair? Then you will write the acid base pair that differ only by one proton is called conjugate acid base pair. ठीक है. सो फाइंड द कॉन्जुगेट एसिड या बेस फॉर द फॉलोइंग स्पीशीज. ठीक है. तो अब देखिए जैसे आपके पास क्या है, HNO2 है. व्हाट आर वी हैविंग, वी आर हैविंग HNO2. ठीक है. तो जनरली दिस इज व्हाट HNO2 क्या होता है, दिस इज एन एसिड है ना, नाइट्रस एसिड होता है. इससे आप क्या करेंगे, H प्लस निकालेंगे. ठीक है. यू आर गोइंग टू सब्ट्रैक्ट H प्लस. आप एक H प्लस निकाल दीजिए, तो हाइड्रोजन हटाया आपने तो क्या बच गया आपको, NO2. एंड पॉजिटिव चार्ज भी हटा तो यहाँ नेगेटिव चार्ज आ गया. सो दिस इज व्हाट, दिस इज कॉन्जुगेट बेस. मेक सेंस, यस और नो, प्लीज टेल मी.
Yes, sir.
ठीक है. अच्छा, इसका कॉन्जुगेट एसिड भी आप बना सकते हैं, बट इट वोंट रियली मेक सेंस बिकॉज इट इज ऑलरेडी एन एसिड है ना. तो यहाँ पे अगर आप ये करेंगे दैट लेट सपोज यू आर एडिंग H प्लस यहाँ पे, देन इट इज गोइंग टू गिव यू एक हाइड्रोजन ऐड कर दीजिए, सो यूल हैव H2 NO2, एंड बिकॉज पॉजिटिव चार्ज इज ऑल्सो एडेड हियर, H प्लस आ रहा है तो एक पॉजिटिव चार्ज यहाँ पे आ जाएगा. ठीक है. सो दिस इज द conjugate acid because we are adding H plus, and this is conjugate base because we are removing H plus. ठीक है. उसी तरह से आपके पास नेक्स्ट है CN नेगेटिव. देन ऑब्वियसली स्पीकिंग CN नेगेटिव में आपको सिर्फ यू कैन ओनली ऐड H प्लस, है ना. आप यहाँ से रिमूव नहीं कर सकते बिकॉज देर इज नो H प्लस आयंस. So if you are going to add H plus, then what is going to happen, HCN. So hydrogen is added and the positive neutralizes the negative. अब अगर HCN से आप निकाल दीजिएगा हाइड्रोजन, then you will get CN negative, that is going to be the conjugate base. Make sense, yes or no? That means this CN negative and HCN, these are conjugate acid base pairs. बात समझ में आ रही है हर्षा?
Yes, sir.
Can you write for the others? HClO4. You can remove hydrogen, you can add hydrogen. F negative में you can only add hydrogen. OH negative में you can do the both things. CO32 negative में you can only add. S2 negative में you can only add hydrogen. Once you're done, you will send it on my WhatsApp.
I've sent, sir.
You have sent. वेरी गुड, करेक्ट। ठीक है, अब देखिए जरा। As you saw, for the case of, let us suppose what? A good example will be SH negative. अब जो आपके पास HS negative है, this can, आप इसमें क्या कर सकते हैं? You can add hydrogen also, plus H plus. This will give you H2S. You can remove hydrogen also because H2 negative is going to be quite stable because of the large size of sulfur atom. So you can remove hydrogen और आपको यहाँ पे क्या मिल जाएगा? Remove H plus, you will get S2 negative. ठीक है? So that means this HS negative, it is going to, rather I should say that it has the ability to add as well as remove H plus. And these type of compounds, so when it is adding H plus, वो hydrogen को abstract कर लेता है, it is gaining H plus, that means it is acting as a base. When it is removing H plus, it is acting as an acid. These compounds are known as amphoteric. They can act as acid and base both. So write next point, substances. Substances that can add as well as remove H plus, as well as remove H plus, and hence can act as acid and base both are called amphoteric substances. है ना? आपने एम्फोटेरिक ऑक्साइड्स के बारे में इस साल भी पढ़ा है, 10th में भी पढ़ा होगा, राइट हर्षा? साइंस में एम्फोटेरिक ऑक्साइड्स।
Yes, sir. 10th.
वही है ना। इसके बाद we will understand about the how the concept of conjugate acid base pairs, it helps us in prediction of some of the strengths of an acid. अगर हम acid की बात करें, then we have A, which is having a hydrogen atom. When it dissociates, you will have A negative and H positive. And let's suppose we have another. We have A, B, C, D, D, and we have here H. एक काम करते हैं, इसको A1 कर देते हैं. Don't write this, है ना? आपके पास A2 है, and then you have H here. When it is going to dissociate, you have A2 negative and H positive. So whenever we are comparing the strength of two acids, you don't have to compare the, you don't have to see even how the H plus are doing, because both of the compounds are going to give you H plus, so it doesn't really matter. Rather, what matter is the conjugate base we are getting. Now, let us suppose if we are saying regarding the stability that A1 negative is more stable than A2 negative. ठीक है? A1 negative is more stable than A2 negative. Now, that means this A1 negative can be easily formed. Since A1 negative is quite stable, the acid will say to hydrogen, hydrogen, you can leave, you can go away. Even when the A atom, it is having charge, A fragment, it is having charge, the A1 negative species, it is having charge, it is still stable. So if it is stable, it can easily lose this H plus ion. And if it is easily losing the H plus ions, that means the concentration of H plus will be greater if we are using A1H, because we are easily losing the H plus ion. And if you are easily losing the H plus ion, that means that acid is strong acid. Make sense?
Yes.
Yes or no, Harsha? Okay. So from here we can say that the strength of acid is basically dependent on the stability of the conjugate base. So I will write first point regarding acids, that strong acids have stable it is not stable. Also, one more thing, if you look, this A1 negative is stable. That means it is not going to attack on the H plus easily. अब ये ध्यान से देखिए, A1 negative is actually a base which could attack on H plus because positive and negative charges. And if A1 negative is stable and it is not attacking the H plus, that means it is not a good base. Base has the work of abstracting hydrogen. It has to attack on hydrogen. Base का काम है हाइड्रोजन पे अटैक करना. But since A1 negative is stable, it doesn't mind attacking the base. That means it doesn't mind attacking the hydrogen. That means it is a weak base. So I will say strong acids have stable and weak conjugate base. जो strong acid का conjugate base होगा, that base will be weak. That is why that base does not attack on H plus to form acid once again. And similarly, you will write weak acids have unstable and strong conjugate base. When the conjugate base will be unstable, it will attack the H plus because it is unstable. It is not stable. It is not stable on its negative ion. It will attack the H plus. As soon as it attacks H plus, now it is behaving as a base. That means it is a strong base. It is attacking H plus and abstracting it. Vice versa, we can write about the bases. That strong base have stable and weak conjugate acid and weak base have unstable and strong conjugate acid. Understood till here, Harsha?
Yes, sir.
Right. Next. Lewis concept. Just give me a second. Okay. So Lewis concept of acid and bases. Now Lewis, what Lewis did was he actually shortened the concept to the atomic space. तो उसने कहा कि acids accept electron pair. They are electron pair acceptor. क्या होते हैं? Electron pair acceptor. and bases donate electron pair. These are electron pair donor, है ना? अब इसको याद रखने का तरीका क्या है, ऐसे समझिए, व्हेन आई से एसिड, व्हाट कम्स इन योर माइंड? एनी केमिकल स्पीशीज दैट कम्स इन योर माइंड, हर्षा?
HCl.
सॉरी, HCl.
Yeah.
उससे बेहतर आई थिंक H+ इज समथिंग दैट कम्स, बट उसका आप कंपाउंड सोच लेते हैं, राइट? एसिड्स H+, मेक सेंस?
Yes.
एंड दिस H+, दिस कैन नॉट गिव इलेक्ट्रॉन ना, ये तो बस क्या कर सकता है, इट कैन एक्सेप्ट इलेक्ट्रॉन, राइट? बिकॉज इलेक्ट्रॉन में नेगेटिव चार्ज और हाइड्रोजन में पॉजिटिव चार्ज, सो हाइड्रोजन H positive, राइट? These two are going to attract each other, so they will accept. Make sense?
Yes.
एंड बेसिस की बात करें हम, तो बेसिस में आपको दिमाग में आना चाहिए OH नेगेटिव। OH नेगेटिव इलेक्ट्रॉन को क्या कर सकता है? इट कैन नॉट अट्रैक्ट इलेक्ट्रॉन, इट कैन नॉट एक्सेप्ट, बिकॉज इस पे ऑलरेडी नेगेटिव चार्ज है, सो इट विल डोनेट इलेक्ट्रॉन। मेक सेंस?
Yes, sir. Like, sir, in the previous one, we said that bases gain H+ ion, right?
हाँ, तो वहां पे जो प्रिंसिपल था दैट वाज H+ आयंस, तो OH नेगेटिव क्या करेगा H+ के साथ? एक्सेप्ट करेगा या फिर इसको डोनेट करेगा, मतलब क्या करेगा?
Mm.
सॉरी, व्हाट वुड हैपन इफ यू हैव OH नेगेटिव एंड H पॉजिटिव? क्या इंटरेक्शन होगा
H2.
दोनों के बीच? हाँ, दे विल अट्रैक्ट ईच अदर ना, इट विल, द OH नेगेटिव इज गोइंग टू गेन H+ ना,
Yes, sir.
है ना? तो देयर द प्रिंसिपल, द मेन पॉइंट वाज H positive, and here the main point is electron. Since the charges are different, that is why accept और donate में differences हैं, तो रटिएगा मत यहाँ पे, है ना? That if you are going to try to memorize it, then it will be difficult, but if you understand it, then it will be easy. कि acids H+ होता है, H+ acid होता है, H+ वो इलेक्ट्रॉन के साथ क्या करेगा, ये सवाल रखिएगा आप। तो आपके आप दिमाग में खुद ब खुद आएगा कि H+ क्या करेगा इलेक्ट्रॉन के साथ, इलेक्ट्रॉन अगर उसके नजदीक आ गया तो वो इसको एक्सेप्ट कर लेगा, और जब OH नेगेटिव आया तो उसको रिपेल करेगा, दैट मींस इट इज गोइंग टू डोनेट। मेक सेंस हर्षा?
Yes, sir.
ठीक है। नाउ इन ऑर्डर टू आइडेंटिफाई दीज थिंग्स, अब जैसे देखिए जनरली इसको ना ऐसे दिखाया जाता है दैट ईच एंड एवरी रिएक्शन मे बी टर्म्ड इन द टर्म्स ऑफ एसिड बेस कांसेप्ट, बिकॉज मान लीजिए आपके पास A पॉजिटिव है एंड यू हैव हियर B व्हिच इज हैविंग अ लोन पेयर इलेक्ट्रॉन द नेगेटिव चार्ज, तो B विल गिव इलेक्ट्रॉन डेंसिटी टू A, और आपको दिख रहा है यहाँ पे कि A और B के बीच में बॉन्ड बन जाएगा। नाउ since B is giving electrons, so it is acting as a base. This is acting as a base, and A is accepting electron. That means it is acting as an acid. ठीक है? So this is Lewis acid base concept, which really generalizes the concept of acid and bases, है ना? जहाँ पे H+ और OH negative रहा ही नहीं. Now we are talking about the atomic level electrons. Make sense, हर्षा?
Yes, sir.
इसके बाद लिखिएगा how to identify these things. तो सबसे पहले Lewis base को identify करने का क्या तरीका है? तो जो Lewis base है आपके पास, Lewis base. Lewis base is species with which are neutral atoms with lone pairs, और Lewis bases are just anions. नेगेटिव चार्ज होगा तो वो anions है ना, which can donate electrons. तो न्यूट्रल एटम्स विद लोन पेयर, इसमें एग्जांपल में आपके पास आ जाएगा NH3 लोन पेयर, इसमें आपके पास H2O भी आ जाएगा बिकॉज H2O में भी लोन पेयर होता है, आपके पास यहाँ पे ROH भी आ जाएगा बिकॉज OH is also having lone pair. You can have RNH2 also because nitrogen is also having lone pair. So these are neutral species which are having lone pair electrons. So all of these can act as bases. And similarly, anions की अगर हम बात करें तो OH negative is going to act as a base. CN negative can act as a base. CL negative can act as a base. BR negative can also act as a base. Make sense? Yes or no? Please tell me.
Yes.
because they can donate electrons. You wrote this?
Yes, sir.
ठीक है, इसके बाद है आपके पास लोवेस्ट एसिड. इसको भी मत लिखिएगा, ध्यान से सुन लीजिए इसके बारे में, है ना. लोवेस्ट एसिड ये क्या करेंगे, इलेक्ट्रॉन पेयर को एक्सेप्ट करेंगे. तो आपके पास कुछ जो है ना, एक तो आपके पास बहुत ही आसान सा एक कंसेप्ट आ रहा होगा कि जो क्या हो, कटायन. एक तो कटायन है, दैट इज ट्रू. कटायंस विल बी लोवेस्ट एसिड. सिंपल कटायंस है ना, सिंपल कटायंस, जिसके बारे में ज्यादा आपको सोचना नहीं. सिंपल कटायंस. So this is the easiest example of, we can say, of lowest acids. What do we have? Simple cation. Simple cations. Simple cation में होगा आपके पास, for example, Na positive. We can have Mg2 positive. We can have calcium 2 positive. You can have Ag positive. And our main acid जो होता है H positive. So all of these are what? Lewis acid. अब इसके बाद there are certain other cases जहां पे there are species which can accept electron pair. ठीक है. Now what are those species which can accept electron pair? ध्यान से देखिएगा. So these are the species which have incomplete octet. Incomplete octet. Incomplete octet such as BF3, boron which is having only 3 bonds. That means only 6 electrons. So if it is not having an electron pair, it is incomplete. That means it can accept an electron pair. Similarly, you'll have AlCl3. Again, same thing. You will have FeCl3. All of these are what? All of these are examples of incomplete octet. So they also have a tendency to accept electrons, and whatever accept electron, according to Lewis, it is what? It is going to be a acid. Okay. We have to flip vertically. Vertically. Next we have इसमें एक बार हम ये भी कर लेते हैं जरा. There are 2 more cases in which we can have Lewis acids. बट इसमें मेन जो है ना, आपको सिंपल कटायन वाला और इनकम्प्लीट ऑक्टेट वाला ही याद रखना है. अदर्स आर नॉट जनरली यूज्ड, इतना इस्तेमाल नहीं करते हम लोग. ठीक. सो नेक्स्ट इज when you are going to have empty d orbitals. These are cases when you have silicon F4. So elements that are after the second period and they are having d orbitals which are vacant. Similarly, you have tin Cl4, you have PF5, like all the complete 3D orbitals, they are vacant. So these can also accept electron. इसके बाद एक केस आता है atoms bonded to more electronegative element via multiple bond. Now these also they have tendency to accept electrons. जैसे कि आपके पास है कार्बन डाइऑक्साइड. So carbon atom that is having a double bond with oxygen like this. So this carbon atom, it is highly delta positive and it can accept electron. As soon as the carbon accepts electron, the pi bond will break and oxygen will get a negative charge, and that negative charge will be stabilized. Because the oxygen atom is electronegative, it can bear a negative charge. उसी तरह से आपके पास है सल्फर डाइऑक्साइड SO2. ठीक है. So this is also an example जहां पे आपके पास it is acting as what? It is acting as a Lewis acid. Please write this down.
Done, sir.
Done. Now we can summarize this. We have acids and bases. And we have three concepts. We have the Arrhenius concept. We have Bronsted-Lowry. And we have Lewis concept. So according to the Arrhenius concept, what are acids, Harsha?
They give
Yes, Harsha?
H plus ions in water.
They gives H plus ion. And bases?
They give OH negative ion.
OH negative ions. Bronsted-Lowry?
Acids gain H plus ions.
No, not gain. They give, na? These are H plus donor. H plus दे देते हैं donor. And these are H plus acceptors. ठीक है?
Yes.
है ना? Lewis में क्या है? This
They
is
gain
electron
pair.
electron pair, donor or acceptor? Acids.
Acceptor.
Acceptors. Very good. And bases are electron pair,
Donors.
donors. Make sense till here? Yes or no, please tell me.
Yes, sir.
ठीक है. So थोड़ा हम लोग और पढ़ लेते हैं, लेकिन I am not going to go into very much details because एक तो ये है that we are going to not meet tomorrow, है ना? हम लोग एक हफ्ते बाद मिलने वाले हैं. तो let us just start with something. The topic is ionic product of water. Just write ionic product of water. So this ionic product of water actually tells about the amount of H plus and OH negative that is present in water. So we know that water, it can auto-ionize into H plus and OH. If H plus and OH negative can be formed, that means no matter how much amount of water we are having, there will be certain amount of H plus and OH negative always there. And constantly H plus and OH negative are being formed, and constantly H plus and OH negative are reacting to make water. That means we have established an equilibrium. So for this type of equilibrium, we write K, it is equal to the concentration of H plus ion multiplied by the concentration of OH negative ion divided by the concentration of H2O. Now, since this H2O is pure liquid, what we can say, हम इसको यहाँ से हटा सकते हैं. And as soon as you remove it, we actually, देखिए हटाते नहीं जनरली, ये 1 होता है और rather it is a constant value, है ना? Because concentration of water is not going to change. तो इसको करते क्या है, इसको इधर भेज देते हैं, because all the constants should be at one place. Then you get actually K, that is multiplied by the concentration of H2O. K is also a constant, concentration of H2 is also constant. It will be equal to H plus into the concentration of OH negative. And this K into H2O, it actually becomes Kw, which gives you the ionic product of water, H plus and into OH negative. Now, the value that is Kw, it is actually a constant for 25 degrees Celsius. So you'll write Kw, first of all, is a constant. Kw is a constant and is determined experimentally. At 25 degrees Celsius, its value is Kw, इसका value है 1.008 into 10 to the power minus 14. ठीक है? And the unit is mole square liter minus 2. ठीक? Now we can approximate this value to very much, we can approximate it to 1 into 10 to the power minus 14, or you can say that kW, it is equal to 10 to the power minus 14. Okay, equal to 10 to the power minus 14. Another thing is that if I am going to increase the temperature, then the dissociation of H plus and OH negative will become easier, and the amount of H plus will also increase, the amount of OH negative will also increase. So essentially, if both of these values are increasing, the kW is also going to increase. Okay, so one more point we can write, kW increases with increase in temperature. So at 25 degrees Celsius, this is the value. This is the value that we are going to take, but this is an important characteristic of kW that we have to keep in mind, that it increases with increase in temperature. Now, next thing also is that we can determine the concentration of H plus and OH negative at 25 degrees Celsius. So what will happen in pure water? In pure water, the concentration of H positive will be equal to the concentration of OH negative, because we have not added any acids or base. And since the concentration of H positive and the concentration of OH negative, this is equal to 10 to the power minus 14, because it is actually kW. So we can say that the concentration of H positive, it is equal to 10 to the power minus 7. And which will be also the concentration of OH negative, because when you are going to multiply both of these 10 to the power minus 7 into 10 to the power minus 7, you will get 10 to the power minus 40. Make sense? Yes or no, please tell me.
Yes, sir.
And the unit will be 10 to the power minus 7 moles per liter. So please copy this down.